The purpose of this video is to show you how you can do the lab report for the acids, bases and pH buffers lab. Now I've got some notes over here. These were notes that I took while I was doing the procedure. You're going to have a lot more notes than what I took here. I've done only 0, 1, 2, 3 drops of each of hydrochloric acid and NaOH for the phosphate buffer part. You're actually going to do 15 drops of each. But with this I'll at least be able to show you how to set up the graph, because I know it can be confusing when you first read it, but this will make it absolutely clear exactly what you need to do when you're setting up your graph. So it starts out, you'll be doing the first part where you had to figure out the pH of each of these solutions and then the colour after the addition of bromphymyl blue. I would recommend that as you go through this you'll see what the pHs are, and to answer this question it's asking about the pH at 13.5. Now that's incredibly basic. 14 is the top. That's the most basic you can get. So what I'd do is I'd look through here, figure out which one of these is producing the most basic solution, and I think that you will probably find that your color will be the same as the one that is most basic. Looking at the questions here, these aren't too bad. What you have to do is figure out the change in pH after adding HCl or sodium hydroxide. Some of these solutions will be more affected by the addition of HCl and NaOH than others will be, and that's pretty much what these questions are about. The next portion involves the phosphate buffer, and this is the table where you will put in the different pHs. So I would go ahead and write down the pHs as they appear in the notes here. They will go into these sections here. Now this is the part that I wanted to show you, and that's the setting up of the graph. So what you'll do is you'll have the graph here, and in the data section what you'll do is you'll put the on the x-axis, that'll be here, that'll be the x-axis, this will be the y-axis down here. On the x-axis you'll have the drops. On the y-axis you'll have the pH. So the data, now here's what it says. It says use a positive, to show the relative magnitudes, use a negative value for each acid and for each drop of acid and a positive value for each drop of base. So we've done the acid here, and what we need to do is, you should probably start at the bottom and work your way up. That's how it'll work the best. So I'm going to start at -3 for the acid, and I'll put the pH in for that, and that is 6.94. Then I go to -2. See, so I start at the largest negative value and work my way up and just put the values in. And then the one drop here. And then 0 drops. 7.21. And then for the base I just start at 1 and I work my way up. So that's the most confusing part, is that for the acid what I did was I started at the bottom and made that negative, and that's what you'll do. You start at -15 and you'll work your way all the way up to 0 here, just putting the values for the pH in each time as you go. And that's all I'm doing. I'm just putting in the sodium hydroxide values now. Now your graph is going to look a whole lot different to the one I'm doing here, because I only did the first three drops of each, and once you've put in all the drops you're going to see something a little bit different. But this is basically what it should look like. You should have 0 here, then minus values down this way, and plus values down this way. So the minus values were for the addition of the acid, and the plus values for the addition of the base. So you'll do that, and you'll do that for all 15 data points. So the next portion involves, suppose you had a buffer containing 0.5 moles of each of the monobasic and dibasic phosphates. How many moles of hydrochloric acid would this phosphate buffer be able to accept? Well, if I had to guess, I'd say probably half a mole of hydrochloric acid. Because what's going to happen is the hydrochloric acid is only going to react with the basic portion, which is the monobasic phosphate. And once it reacts with the monobasic phosphate, there won't be anything for it to react with anymore. So, so the answer to that is actually half a mole. The way to figure out what the conjugate base and the conjugate acid is, the conjugate base is always the one, well actually to make a conjugate base you take off H+, to make a conjugate acid you add H+. So you look at the two and you ask yourself, well, which one looks like it's had hydrogen removed or H+ removed? It's probably that one if I had to guess. Alright. Why do you need both to resist changes in pH? Well, you need both an acidic portion and a basic portion to form a buffer. That's really the reason that you need that you'll get changes in pH. You'll need that to resist changes in pH, because if you add acid, it'll be the basic portion that will react with the acid, and if you add base, it'll be the acidic portion that reacts with the base. So you need both in there so that changes in pH can be resisted. Alright, if you made up a phosphate buffer with only half as much of this as compared to this, well, what would happen is if you were to, this is the acidic one, so if you were adding base to this and you only had half as much of that as you had of that, then what would happen is the buffer would get overrun pretty quickly, because it would react with all of this acidic portion very quickly, because there's only half as much of the basic portion there. So that's why it's important when you're making up a buffer to have equal amounts of both portions of the buffer, both the acidic and the basic part. And the rest of it you can answer on your own.